Hi there everyone, welcome back to another OCR Further Maths video. Today we'll be covering question 5 from the 2020 Pure Core 2 paper. So as you can see, this paper is on second order differentials, which is one of the last things you'll learn. Usually this kind of question when they're in the middle of the paper are fairly simple, but there is a part of this which makes it slightly harder and where lots of people could get stuck. So I'm just going to go through this question. Pretty interesting one, and it's applied to capacitors. So it's interesting, it's probably even more interesting if you study physics. So it says a capacitor is an electrical component which stores charge. The value of the charge stored by the capacitor is denoted by Q. It's placed in an electrical circuit. At any time t seconds where t is greater than or equal to 0, Q can be modeled by the differential equation given. Initially, so when you see the word initially, straight away you should think of t equals 0. So when t equals 0, the charge is 100 units, so Q is equal to 100. And it's given that Q tends to a finite limit as t tends to infinity. So we'll write that down as well. As t tends to infinity, Q has some value which we don't really know yet. So then we say determine the charge on the capacitor when t is equal to 0.5. So if we're trying to find a solution for Q from a second order differential at a certain time, we'll have to first basically be able to solve the differential equation and then find a particular solution. So the first thing we're going to do is use the auxiliary equation, which you should have heard before, and we're going to basically use that to find the general solution. So I'm just going to write auxiliary equation, like that, AE, and then we're going to do it. So it's m squared, so no coefficient there, then it's minus 2 dq over dt, so it'll be minus 2m. Then we have minus 15q, so it will be minus 15 equals 0. And then I'm going to solve this second order, this quadratic, sorry. So first I'm going to factorize, and it's going to be m minus 5 m plus 3 equals 0. So this would give us that m is equal to 5 or minus 3. Then we're going to use this value of m, the solution, to put it back into a general solution. So here we know that there are two real roots that are given from this quadratic. So then we're going to use the general kind of solutions that we know. So if we have two real solutions, we know that using y and x, it would be y equals a e px plus b e to the qx, where p and q are the solutions. So here we have 5 and minus 3, and a and b are just some arbitrary constants. So this would mean that if we, instead of y and x, we use q and t because those are the variables given, our general solution, so our GS, would be q is equal to a e to the 5t plus b e to the minus 3t. So this is our general solution. But if we plug in t equals 0.5, that doesn't really tell us yet what any value of q is because we have those arbitrary constants a and b. So then what we have to do is we have to use the conditions we've been given here of t equals 0 and q equals 100, and t tends to infinity and q equals some value. Because we have two constants, we need two things to solve the simultaneous equation, is basically what I'm trying to say. So if we plug in t equals 0, the first one, that seems pretty simple, then what we'd get is, so q is 100, so we'd have 100 equals a e to the 0, because 5 times 0 is 0, plus b e to the 0, because minus 3 times 0 is 0. E to the power of 0 is 1, so that gives us our first equation, which is 100 equals a plus b. Then we have to use the second part, which is saying as t tends to infinity, q tends to a certain value. Now, we know that if we have e to the minus anything, then we have a graph, right? So our e to the t graph would look something like this. This is what e to the 5t would look like. And if we have our e to the minus 3t graph, it'll look something like this. This is e to the minus 3t. So we can see that as t tends to infinity, so if this is infinity over in this direction here, e to the minus 3t tends to a certain value. But as we go in this direction here and t tends to infinity, e to the 5t actually doesn't tend to a finite limit, it tends to infinity as well. So that means that this value here, this part of the equation, must basically not be present in our final solution, in our particular solution. So basically what we can say is a is equal to 0. This part a is equal to 0 because we don't have any part of e to the 5t in our final solution, otherwise it wouldn't tend to a final limit. So now we can solve our simultaneous equation and say 100 equals 0 plus b, so b is equal to 100, and then we got our particular solution, which is q is equal to 100 e to the minus 3t. Notice how I haven't done any particular integral in this final solution, or even in the general solution, for example, because we have equal to 0 here. If we had equal to cos t, for example, or maybe e to the 3t as on the right hand side after the equal sign, then I'd have to do a particular integral. But because it's equal to 0, there is no particular integral for this question, which makes it a lot easier. So now we have basically our particular solution, and what we have to do is determine the charge q when t equals 0.5. So we just plug in 0.5, and that gives us 100 e to the minus 3 times by 0.5, which is 100 over e to the 1.5. And you could find a decimal value for this in your calculator, but this is also a correct answer. So that's part A completed. The maths with the second order is easy. It's just finding the particular solution and thinking about your graphs and applying the sort of harder problem-solving math side to it, which is slightly harder in this question. So that's part A done. And for part B, we are meant to determine the finite limit of q as t tends to infinity. So we have already thought about this, but if we redraw the graph, let's say for part B, if we redraw the graph, it looks something like this, where at t is equal to 0, it would be go through 100 here, and basically what we can see is that q tends to 0. It never reaches 0, it's asymptotic with the x-axis, but q tends to 0 as t tends to infinity. So that's this question done. Fairly simple to get all the marks if you remember your general solution. So you remember to obviously have your general solutions for if there are two roots, if there is one repeated root, or if there are complex roots. Then you also have to be able to kind of think about your graphs and how it tends to infinity, which is quite common in second order differential questions, or first order differential questions for that matter. So thank you for watching this video, hope you enjoy, and I'll see you in the next one.